Hi, this is Kevin Hill, and thanks for stopping by my video. My Twitter handle, and I'd love for you to follow me if you enjoy this or want to see any more DBA fundamentals type stuff, is at Kevin3NF. You can follow along at my blog. Just go to dallasdbas.com, and there's a blog link, and I do all sorts of fundamental DBA presentations or things that I've learned recently and just want to share with the world. Today, and this came out of a presentation I did on basic backup stuff in a DR scenario, and I mentioned several times that you can restore databases to a specific point in time, but I ran out of time to actually do that demo. So this is a very common interview question is, if I want to restore to such and such a time, can I do that? And a lot of non-DBAs or junior DBAs maybe have heard of it but don't have any idea actually how to do it. So that's what we're going to do today. It's going to be fairly simple. I'm going to run some stuff in scripts just to populate databases, but we're going to do the actual restore in the GUI so that you can follow along. You can pause the video. You can set these things up on your own using the same ideas and concepts that I'm using. So without any more stalling, let's get right to it. What I've got here is a SQL Server 2014 dev install on my laptop. This is not, there's nothing in here, some goofy database names that don't mean anything, and most of them don't have anything in them. So what you are looking for here is just what you see, and then we're going to create a couple databases. You'll see those. I don't have them right now. You'll also see me pop over to this window from time to time. Down here is where we're going to see some backups actually get created. So as I pop over, you'll know what you're looking for. Between this folder and this file, you'll see them jump in. All right. Like I said, I'm going to do a lot of this in T-SQL simply because it's easier than right-click, edit, and adding data manually. The very first thing I'm going to do is I'm going to create two identical databases, one called FullDB and one called SimpleDB. The full one is in the full recovery model, and this is a key point. If you don't know what recovery models are, essentially they're telling your database how to behave when crash recovery comes in, which happens after a crash or a SQL Server restart of the service or the server itself, or when you restore a database. All of the process involved, basically that's just SQL Server getting the database ready for use. So when it comes back up, there's certain things you can and cannot do. It rolls forward through some transactions, a bunch of stuff that isn't really related to the point in time, but there's a difference. Full recovery behaves one way, simple recovery model behaves another. So I'm going to run these and execute that and refresh my databases, and you can see I've got FullDB, which is the one here, and I've got SimpleDB, which is here, and they do have the different recovery models set, unless I completely mess something up between rehearsal and now. So we've got full recovery on that one, which is good because that's the FullDB. Right click, properties, options, and we have simple on this one. Very important to be able to demonstrate the difference between the two. Spoiler alert, you can't do point in time in simple recovery model. And I'm going to show that to you. And then I'm going to tell you why. Now, just so we can create some data and actually have a place to put it, let me make this just a bit bigger. I think, yeah. We're going to create on the FullDB and on the simple identical tables. There's nothing fancy about this. It's just a basic two-column table with an identity field and some text. So those are both created. Go in here. There it is. Go into the SimpleDB, and there it is, there and there. So those exist, and we're going to dump some data into them. But very first thing we're going to do, because I like to do this anytime I create a database, we're going to run a couple of full backups, initializing the file and compressing them because those are good practices. In real world, I'd have date timestamps in my file names, and I'd have the full path. These are going to my default path, so that's why it's not listed there. So execute those, pop over to the window, and I see my full and my simple. See, I told you stuff was going to show up there, and there it is. All right. Now, let's put some data in here. I'm just going to insert the text full database in the full, and in simple database in the simple DB, and I'm going to put it in there 10 times. That's what the go 10 is for. And just to show that I've actually done it, because I don't like having one row affected on down the list, I'm turning off the whole no count or the count thing, and I'm just going to count at the end. So it's just going to tell me 10 rows, 10 rows. Keep that in the back of your head that I've got 10 rows in table 1 in each database. So 10 in one, 10 in the other for a total of 20, but they're not the same database, so it's not the same thing. All right. If you were doing the typical scenario for backups is a full backup on, maybe Sunday, the other 6 days of the week, maybe a differential, and then periodically throughout the week, maybe 15 minutes, maybe an hour, depends on your environment, you'll do transaction log backups. In simple recovery model, you cannot do transaction log backups, and that is critical to the point that I'm making and the example I'm going to show you. So I'm going to do a differential just because I like to have a full diff and T-logs. Running it on both, and this will work for both of them because you can do fulls and differentials on either recovery model. All right. So now that we have a differential, we have a backup on file that has the tables. We have a backup on file that has the data in it, some data in it. Now we're after the diff, so I'm going to put 5 rows into each of those tables. Again, full DB, simple DB, and count the rows. So if you were following along, we had 10 already. We're going to have 5 more now for a total of 15, unless my math is wrong and I have to restart this video. Nope, we're good. I've changed these numbers quite a bit as I'm setting this up. So inserts are working just fine. It's a normal database. You would expect these to work exactly like that. Now, because I like to have a full differential and then periodic T-logs, here's your transaction log backup. It goes from backup database to backup log. And you can do all of this through the GUI if you want to, if you're more comfortable there. That's perfectly fine. It doesn't lend itself to running this a dozen times prior to recording a video, though. All right, so we'll take a transaction log backup, and you're going to see an error here. That is intentional, and it's key to the discussion. All right, for full DB, the backup log successfully did its thing very quickly because it's only got 15 rows, as you would expect. This backup log statement here is this one here in the red text, and it says, dude, bro, you can't do that. I'm in simple recovery model. It actually said, dude, bro, you just didn't hear it. All right, that's normal, that's expected. That is the main difference, and to simplify it a little bit, there's a lot of nuts and bolts around it. In full recovery model and bulk logged recovery model, which we're not going to get into, you can back up the T-log, which means you are backing up the individual transactions if you actually do the backup. In simple, you cannot back up the log because it purges its own stuff out. You would use that for like dev environments or read-only databases, things like that. But that's being able to back up the transaction log is incredibly important and is absolutely key to when you try to restore to a point in time, which is the whole point of this video. I know I've said that already several times. So we've got a log backup from the full database. Let's go look at it. I've got my full for the full DB, my differential for the full DB, and I've got a transaction log. It says so right here in the type. These are the normal industry-wide extensions. You can call them whatever you want, but please stick with these because that way the DB that comes after you will know what you've done. For the simple, I've got the full that we took, and I've got the differential, and there's no TRN because that one failed. That was the red text earlier. So I don't have that. Now we've deviated in what we've got. The data is exactly the same still. So if I were to go and run just some selects on those two tables, it's still going to show me 15 rows. Awesome. Let's do, and I'm not going to need this at the moment because I'm going to update that. I'm going to insert hypothetical situation. You've got a fairly small company. Somebody comes in and gives you the biggest order in the history of time. It's $1 million sale, and everybody's going to get a huge Christmas bonus. Awesome. We don't want to lose that data, correct? Correct. So insert the record of that $1 million sale into our table. Works just fine. Now we're up to 16 rows because we did $1 million sale in each database. And I'm getting the date and time for a very specific reason. I'm going to copy that, and I'm just going to make a note of it, and you should too. 1932, 7:32 on my laptop, which is funny because I'm sitting in Eastern time zone, and it's actually 8:32 right now. All right, now 1932:32. If I stall for just a few more seconds, I might be able to get the clock to roll over to 7:33. Yep, it just did. Awesome. Now, somebody thought they were in dev and they wanted to clear off some space in the database, or they were running some test code or something, but they were accidentally connected to your production databases. That's bad. You should control security better than that. Shame on both of us because we've all done it. So we're going to do a delete statement, and that $1 million sale is going to disappear from both the full and the simple DB. All right, and we're going to get the date and time of that. And we're going to copy it. So now we're down to 15 rows in each database. the data is still exactly the same in both databases because we've done everything same way to the same. And for those of you that haven't seen it, this three-part naming is database name, schema, table, just in case you've never seen that. You can actually, it's four-part naming. You can put the server name in there as well. This is all local to me. So if it's three parts, it just assumes local server. A little extra bonus for you there. So again, we're going to attempt to take a full transaction log backup because we want to make sure we back up that $1 million. We want to be doing regular transaction log backups. We want to be doing that. We want to have backups of everything, and we want to capture all the data that's important to us. But as our maintenance plan or our scripts are running these log backups, they don't know someone goofed. They don't know this delete happened. They're going to back up everything that happened. So we execute. Again, we have the red text from the simple DB because it still can't do transaction log backups, as you would expect. And the full DB, this is the third, might be the second, but it's a different file than the previous one. So I have more than one tlog backup now. So now somebody just figured out that the $1 million sale, the record is gone. If I go in here into the full database, and this should work, it should be the same on both of them. I don't have that script, unfortunately. If I do the top 10 rows and then I change it to 100 because I don't default for some reason, and my insert button is telling me that I need to do that. Okay, if I do this and rerun it, it'll show me full database. That was the first batch, and then these 15 records. If you'll notice, the $1 million sale is gone. This is everything. Select top everything from that table. If it was there, it would be there. If I just change this over to simple, instead of going in and redoing all of that, and run that, simple database after the diff backup. The $1 million sale is gone. That's bad. Everybody should panic now. So what you're going to do is you're going to go back and look and see when that happened, because in theory we know when somebody messed up. In an ideal world. The world is not ideal, but we're going to pretend that it is. We're going to know that the developer or whoever the CEO did this. He was trying to monkey around the databases, and he shouldn't be allowed to do that. So he ran this statement at 7:33:33. So we want to go back to a point in time prior to that, which 7:33 would work, because at 7:32 we had good values. We knew the $1 million sale was here. We had backups. But in order to catch 7:33, you have to go to the log or to the backup after that, because it'll be contained within a backup always pulls old information. That's what it's backing up when it does it. Makes perfect sense, right? So this is where I said I was going to go over to the GUI for you instead of just trying to show you a bunch of T-SQL script, because odds are if you're looking at this and learning from it, you're probably not all that great at T-SQL yet. You don't have all the nuances down. I'm sure you're brilliant, of course, but we're going to do it through the database just because it's easy. Now, most of the time when I do a restore, I wind up restoring it to a new database on something like this, and I copy over the missing data, as opposed to overwriting the existing database and maybe losing more information. So I go in, restore database, brings up the GUI, and it shows me for the full DB, these are all the files I have to back up from that it knows about, or that the SQL Server knows about. I've got my full database, or full backup. I've got my differential, and I've got more T-logs than I would have expected, because my maintenance plan is probably running. Yep. If it says Kevin here, these are the ones I just did. This is the one that has been running in the background through my maintenance plans and some other scripts that I should have stopped. Anyway, where you want to go in here, if you know what time it happened, you hit this timeline button, go to a specific date and time, and we've been talking about 7:33 quite a bit. Let's just go there exactly and tab off of that. Double check, make sure it didn't change, because sometimes it gets a little buggy, and it does. So 7:33 p.m. This is today. Matches down here. I'm going to hit OK on this, and that doesn't do anything but set a time. Notice that the number of files over here changed. One of these is missing. So it incorporated my time request. And this is a really cool feature if you've never seen it. Hit the script button, and behind the scenes, it'll show you exactly what it's doing. And I'm just going to actually show you that. It's going to, I don't really need it to back up the tail with a log, but that's okay. Let me just take that out of there for clarity's sake. If we run this, we're going to get, it's going to restore the full backup, the differential, It's got that extra funky one in there from my script. And then the two that we took, DB, TRN, there's one key little piece in here, right here. This is the interview question that just ran off my screen. When somebody says, how do I do a point in time restore, you ask them two questions. Is it in full or bulk logged recovery? If they say yes, then you tell them you do the log restore using the stop at command on the very last log you restored. Now you may have to do 100 log restores, just depending on how your setup is. But the very last one was created in this case. I don't have the exact time that it was created. I bet I do in this screen over here. Yep, this one was done. I don't have it, sorry. Anywho, the stop at command, and then you give it a properly formatted time. In this case, 7:33. That's exactly what we picked in the GUI. Now, if you're confident in your GUI skills, and I'm sure that you are because you're amazing, you go over here, you've already set your time, set your options, but you want to make sure that you don't overwrite the production database. I typically give this kind of situation a very similar name, underscore restored, or maybe even underscore KBH, which are my initials. Hit OK, bada bing, bada boom. This should take almost no time because it's a tiny, tiny database. It's actually taking a lot longer than I would have thought. I don't know why it's taking so long. So I'm going to stop it. And I'm going to go over here, and I'm going to uncheck that box that wanted to do a tail log backup. And I'm going to hit OK again and hope it works. Bada bing. There we go. Much better. Now, look, I've got a new database right there. Full DB restored. That's the one we just did. If I go in here and I look at table 1, and I cross my fingers and hope that this worked like I wanted it to, and put a 0 in there to get actually all the records, my $1 million sale is back. Because it was deleted after 7:33, I restored right up until the point before that deletion because I was lucky enough to know the time. It's very common when you're trying to figure out the time that the first thing you're going to do is go to the log files and see which one is big because somebody deleted a whole table, or you're going to have to do, write a script or have SQL Server write a script for you where you roll through transaction logs. Is that the problem? Okay, we need to back up a little more. We need to go, 15 minutes earlier. And then you restore again and again and again until you find the point in time that you actually want to restore to. But when you do it, you can do that through the GUI, or you can type up your restore database and restore log commands using all the normal features, the file one, and typically you don't need all that stuff. This is why does my screen keep jumping? This is the most important part of the entire conversation and the entire reason I'm recording this for you. The stop at simply says, okay, log file, you've got 57 transactions. Stop at whatever transaction number you're on or we're on at 7:33 p.m. in this case, whatever time it is for you. And then any transaction log that was transaction that was backed up in that TRN file is then ignored, and SQL Server does a recovery of the database, and it's available for use. And that's when you get to go start gluing the pieces and parts back together and running queries to get the missing data inserted into the live production database. And that's a whole nother conversation. But remember, stop at comes up in almost every interview I've ever had, and I've been doing this for 18 years. So just if you want to see them, there's all the files that we created. There was one more created somewhere. It's probably sitting over in here. Yep, there it is. That's 7:35, 7:30. And those are the ones that got in the way a little bit on me, but that's okay. If you have any questions on this, need clarification, feel free to stalk me on Twitter at Kevin3NF. I don't have a blog on this yet, but I will. And you can also do comments. This is on YouTube, obviously, because that's where you're watching it. Ask a question in the comments related specifically to this, and I'm more than happy to help. I also take emails, kevin@dallasdbas.com. I can't promise you that I'm going to answer you in 5 minutes. It might be 5 days, but I will do everything I can to get back to you on this. I love, love, love helping people learn the fundamentals of SQL Server to the best I can teach them, so you don't have to Google everything all the time, and you actually understand things, and they make sense to you. Little blurb about my company. Quite simply, we do remote DBA work for pretty much anybody in the United States. I don't go outside the borders. I don't do development, I don't do BI, I don't do that kind of stuff. But if your DBA is on vacation or you don't have one, get in touch with me. We can help. That's all I've got for you. Thanks so much.